Yeah, today we will be going to solve uh, simulation problem in finding bubble point pressure and dew point pressure. Similarly, we can also see bubble point temperature and dew point temperature. But first of all, let us actually look at this particular problem of evaluating bubble point pressure and dew point pressure. So let us look at the problem here. This problem says, this is taken from thermodynamics textbook. The system acetone, acetonitrile, nitromethyl. This is a ternary system in which first component is acetone, second component acetonitrile, third component nitromethyl. At 80 degrees centigrade and 110 kilopascal has the overall composition Z1, Z2, and Z3. So Z is the composition of each component, which refers to in the feed. Assuming that Raoult's law is appropriate, assuming that Raoult's law is appropriate to this system, the problem says to determine LV, that means liquid flow rate, vapor flow rate, and liquid phase compositions and vapor phase compositions. The vapor pressures of the two species at 80 degrees centigrade are already mentioned here. Okay. So as per the calculation, theoretical calculations or using Raoult's law, using model calculations, the estimated bubble point pressure is around 130 to 32.4 kilopascals and dew point pressure is 101.52 kilopascals. Now let us see in what way this can be seen in what do you call uh, DWSIM simulation. So let us open DWSIM now. I'm again sharing and I'm going to the desktop actually. Let me see if I can actually open the desktop. Yeah. So let me open DWSIM, which I will be opening, and then yeah. Now I'm opening DWSIM here. You can see this is the DWSIM console. Let me stop the video, my video here. I'm saying I don't want a newest version. So this is a DWSIM platform. Let me go to or create a new file. And as the problem said, now we are going to find bubble point pressure and dew point pressure for a system given. So acetone, acetonitrile, nitromethyl. So first case, in the first instance, I have to introduce the compounds. So here this window appears, and then we should say next. And then it asks me in the search bar, I type acetone, and I can tick this checkbox here. Otherwise, I can double click here, or if I press acetone, type acetone, and then press enter, automatically it will be selected. Next one is acetone nitrile. Again, I press enter. Nitromethane. Again, I press enter. So the compounds are given. Now, the second next one is I can take Raoult's law directly because the problem said Raoult's law. So I can add it here, and then this is a VLE which is selected here. Already VLE selected. We'll take VLE, and then next. Now I choose here C5 system of units. Our pressure is in kilopascals, so I set the kilopascal pressure, but temperature is in centigrade only. I don't change this, and I say enter. Okay, so this is all done as per our particular system. So now let me go to finish, and then I go to settings, thermodynamics part. Already I've chosen Raoult's law, right? Done. Now I take a material stream here and I drag and keep it here. Let me maximize this if it is possible. Yeah, so this is, I'm maximizing it. Let me rename this as rename. Now the compound stream conditions, I specify here 1 kilomole. I press enter. Automatically the conversion is seen here, and the compound amounts acetone is given as, let me see if I can, yeah, if I can actually place it there so that it will be easy for us to, let me see if it is possible here. No, it is not possible. Okay, so acetone, I say 0.45, acetonitrile 0.35, and nitromethane 0.2. So then I press accept. It done. Now again come back to stream conditions. Now I want to calculate bubble point pressure. Okay, what is that I am trying to calculate? Bubble point pressure. So how do I do that? So let me introduce text here. Yeah, so this is a text box. So let me see if I can do this. Yeah. Okay. Okay, let's not worry about it. Okay. Now I am trying to calculate the bubble point pressure. So here in the flash spec, you see here in the flash spec here. So let me annotate. Then let me show you this. Yeah, in the flash spec here. So you can see this here. This one. This is the flash spec here. Sorry. Yeah. So this is the flash spec here. It is mentioned here as temperature and pressure. Okay. Now what are we calculating? Bubble point pressure. Okay. I write here BUBB. Let me write it as bubble point pressure. Let me remove all these things here. Okay. Come back. Now I select here temperature and vapor fraction. That means TV here. That means I specify here temperature. If I specify 80 degrees centigrade, because the problem says 80 degrees centigrade, and the vapor fraction here, the vapor fraction what you see here is actually the vapor fraction what you see here, it is given as 0. If it is 0, that means it is at saturated liquid condition. That is bubble point we can actually obtain. So I do that and then I press enter. If I do this, automatically see it is the temperature has not been taken. So if I say 80, press enter, and then vapor fraction is 0. If I have calculated, the value here is 80 degrees centigrade. I come to this feed condition here, and then you can see the temperature here and the pressure. Pressure is now 141.215 kilopascals. That means this is the dew point pressure. Sorry, bubble point pressure, because I am saying there is no vapor fraction. This all liquid compositions are given. Now the same condition, same the compositions which were given, if I assume it to be as 1, that means vapor fraction is 1. I say now it is at, now we are calculating at a given temperature, and all the compositions are assumed to be as vapor phase compositions. What is the dew point? Now the dew point here is shown as 104. Now you see temperature is 80 degrees centigrade, pressure is 104.264. Now if I same thing, if I plus results and then if I go down, now you can see here results is all acetone, acetonitrile, and nitromethane are shown, and properties you see so nothing is there, and anything else we can see here from this. I think it is not an issue. Now it says vapor. You can see here. Now it says this is all vapor. So if I say the amounts, this is all vapor. Now similarly, if I again come back and I make this as what do you call vapor fraction to be 0, let me check the I have to press enter. Now let me go to results and then phase properties. You see now if I say phase properties, it's all now the compounds and it is liquid phase now. See, so what all compositions are specified, we are assuming them to be as liquid phase. So this is how we calculate the bubble point pressure and dew point pressure. Let us summarize. So what are we trying to see? What are we trying to see is that for a particular system, the ternary system, temperature is given as 80 degrees centigrade, and it is asked to actually find L, that means liquid flow, vapor flow, and their compositions. So first of all, we need to check whether the given pressure falls between bubble point pressure and dew point pressure. That's what we have calculated. We will see in the next class how to calculate bubble point temperature and dew point temperature with another example.